Now, the relation between differentiability and continuity. As I said previously, a function is continuous, definitely the function will be differentiable. But if the function is differentiable, so we have to check the continuity. We are not sure that the function will be continuous or not. But normally the function is not continuous means it will not be differentiable. Okay, so function is continuous, then function will be differentiable, may or may not be. We have to check. I'm not saying that sure it will be differentiable, but function is not continuous means definitely the function is not differentiable. So same thing here. If my function is differential at every point in domain, then it should be different. It must be continuous in that domain. Domain means what basically? Domains mean input. So if I'm saying that my function f of x, okay, if I'll take this as a function as sine x, let us suppose this example, if I'll take this as sine x, so sine x is my trigonometric function. For domain of sine x is basically all real number. So domain for sine x is nothing but r. But what will happen for the differentiability? It means if the r is continuous, the sine x is continuous in r, then definitely the differentiable function of this, it means if I'll differentiate it, it comes as cos x. So we know that cos x domain is also r. It means it is differentiable in its domain only. So this is very, very important. When a function is differentiable at every point in domain, it must be continuous. So we can say that sin x is already continuous in its domain, and it is basically differentiable also in its, when we differentiate it, so it will be differentiable in its domain. Okay, that is the most important point. Domain, again I'm telling you, input. What is input here? X, which is called as all real number. So we can use any real number for the sin x. That input is possible. Okay.